Now, this video lesson is a continuation from where I stopped in the last lesson. Talk started by explaining how to determine the resultant of two vectors by triangle method. Now, I want to give you a formula for calculating the resultant of two vectors by triangle method, and also try using drawing method as graphical method or scale drawing method to find the resultant of two vectors. Now, suppose you are given, for example, we have a box that is being pulled by two forces. This is a box placed on a surface, and two forces are applied through two different ropes to pull this box. A force of 50 Newton acts in this direction. Maybe somebody is here, pulling this box in this direction. He applies a force of 50 Newton. Maybe someone else is here pulling this same box in this direction with a force of 30 Newton. And that the angle between them, for instance, is 60 degrees. Now we want to find the resultant force, because it's the resultant force that is actually responsible for the motion of this box. You don't expect the box to move in both directions. It will move and also move here. So the box will move in the direction of the resultant force, which we are going to find. First of all, by calculation method, we try to redraw this diagram. This is the force. Let me call this force F1. Let me call this force F1. I call this one force F2. Now force X1 is acting this way, both in magnitude and direction. I want to redraw that here, just the way it is acting there. This is my F1, acting along this line. The magnitude is 50 Newton. Okay. Now, the rule of triangle method of adding vector is that it is vector A followed by vector B. We are going to join the head of vector F1 to the tail. The tail of vector F2 is here because this is head. Okay, we're going to join the head of vector F1 to the tail of F2. So I will detach vector F2 just the way it is. I'll bring it down and connect it to the head of vector F1. Okay, this is my F1 and this is my F2, which is 30 Newton. Now, what's the angle between the two vectors? 60 degrees. Where do I place my 60 degrees? It will be wrong for me to place the 60 here. And then I need to produce this vector F1 like this. I'll extend this line so that my 60 degrees is here. This angle here is the angle between the two vectors. If we place 60 degrees here, it will be very, very wrong. Because the two vectors are acting at 60 degrees to each other. So it is this line. Of course, you can agree with me that this is still your vector F1. Look at it. By extension, this is F1. And by extension, this is F2. So what I have here is same thing as what you have here. Okay, so that's why this must be 60 and not this. So that this angle here, the interior angle, will now be 120 by straight angle theorem, that the sum of angles of a straight line is 180. So this is 60, this will be 180. So that the resultant vector quickly is represented in magnitude and direction by this line. Okay, I can call my resultant R. How do I find the resultant vector? So I have to use my cosine rule because I have two sides and one included angle. And the cosine rule says that if you are given three, different, given a triangle with two sides and one angle, then r squared is equal to f1 squared plus f2 squared minus 2 times f1 f2 cos theta. Okay, theta is now this 120. This my theta degrees is my 120. Okay, so I have my r squared equal to f1 squared plus f2 squared minus 2 f1 f2 cos 120. Okay, so we need to see that clearly. So what's my f1? 50. What's my f2? 30. So my resultant squared is now 50 squared plus 30 squared minus 2 times 50 times 30 cos 120 degrees. That gives me 2500 plus 900 minus 3000. That is 50 times 30 is 15,000 Sorry, 1,500 times 2, that's 3,000 cos 120. Now, cos 120 is the same thing as minus cos 60, which is minus 0.5. Okay, you can confirm that your calculator. That gives me 3,400. That is 2,005 plus 900. Gives you that minus, this gives me 3,000 times 0.5 negative. Okay, sorry, I've already made this positive. So that gives me 3,400 plus 1,500. So that will add up together to give me 4,900. That is my R squared. So that my final answer for the resultant of these two vectors is the, okay, square root of 4,900 is actually 700 Newton. Oh, sorry, 70 Newton. That's the square root of it. So that's the resultant vector, 70 Newton, when the angle between them is 30 degrees. Now, the direction of the resultant vector, we can place this alpha degree here. This alpha degree represents the direction of R of the resultant vector. This 70 Newton is the magnitude of the resultant vector. So R becomes the resultant of that vector. We can use the sine rule. Sine rule. So for the sine rule, let's say you are given a triangle ABC, you know, let's say this is my A, B, and C. And this is my side B, opposite angle B. This is my side C, opposite angle C, and this is my side A, opposite angle A. Sine will say that sine of angle A, this angle here, over side A, the ratio of that equals the sine B, angle B over B, is equal to sine C over C. So to find my resultant here very quickly, I will first of all look for the sides that are known and the required angle. The required angle is alpha, and the side opposite it, this side, is also equal to, okay, that's your 30, that's your F2, 30. So that gives me sine alpha over 30, because this is side opposite to the angle alpha I'm looking for. Okay, the angle, the side opposite it, then that equals sine 120, which is this known angle, over the side opposite the angle, the resultant, which we got here at 70 or thereabout. So that gives me sine alpha over 30 is equal to sine 120 divided by 70. So when I cross multiply, I'm going to have 70 sine alpha is equal to 30 sine 120. So that sine alpha equals 30 sine 120 divided by 70. It gives me 0.37115. So alpha gives me the sine inverse of 0.37115. That eventually results in our answer, which is 21.7 degrees. So that is the direction of the resultant vector. So this is how to calculate, to determine the magnitude and direction of two vectors that are acting, at a particular point, that is both acting on these objects by triangle method. So in the next video, we're going to see how to use the second method, parallelogram law of vector addition, to find the resultant of two vectors.